So the topic of today is perceptron. So what basically is a perceptron? A perceptron is basically, you can say, another name for a neuron. So what is a neuron? We will first of all deep dive into it, and then we will understand what is a perceptron. So a perceptron is just an artificial copy of a neuron. A neuron consists of several inputs, and all of these inputs are processed in a nucleus, and the nucleus can be named as hidden layers when talking about a perceptron. And after it's processed, it is then linked, and an output is generated, and that output is received as an input to other various neurons, and that is how a neuron works. So basically, lots of inputs, and then a processing, and then output. So that is how a neuron works, and perceptron is basically similar to a neuron. It consists of different input nodes, which are then processed, and then an output is given out. So it would be like, first of all, we provide input. Let me just make this picture small. So the input provided is called x1, x2, like as shown in the picture, x1, x2, x3, and up to xn. These are all of the inputs that this input can be basically any data set, or it can be images, or it can be anything that can be provided to a neural network as input. And w1, w2, w3, and up to wn, these are called weights. And the purpose of weights is that they connect uh, all of the different nodes in a neuron, and all of these nodes, all of these inputs combine to form a z. So let's first of all explain. This is called a Z, and it is a node at which the inputs of all of the neurons has been gets together, and then what happens is, like, this output is then given to a step function, and that step function generates the output. So let's deep dive into it. So what is Z? So what is Z? Z is basically W1, X1 plus W2, X2 plus B. There are two parts inside of a perceptron. One is its training, and the other is accuracy. X1, X2 are basically the values that we are actually giving it as an input, and W1, W2, and B are predicted by the perceptron during its training. So Z is either predicted as a 0, or either it is predicted as a 1, or any number in minus. So happens is that what happens is that if our output is 0, or it is greater than 0, if Z is greater than equal to 0, we call it 1. If Z is lesser than 0, then we call it a 0. Let's say we want to predict a picture, like as shown. uh, we want to predict a picture. So let me just increase its size, in which we want to predict like two classes of red dots and blue dots. So what happens is, if our answer is greater than equal to greater than or equal to 0. So this is basically 0, so not it's not 1, it is 0. So if our answer is greater than equal to 0, what we call it is uh, we call it that this particular thing belongs to this certifying class. So like either it can be a cat, it can be a number, or it can be any prediction that we want. It can be a 1 or it can be a 0. So this was a basic intro of perceptron. So a quick revision: inputs called x1, x2, and then there are weights, and then they combine to form an equation. And z it is basically similar to a line equation. What is a line equation? Line equation is ax plus by plus c. So it is similar to a line equation, and w1 and x1 plus w2 x2 plus b, they combine to this equation gives us in output as a z, which is then provided to a function, the step function, and we will talk about that later, and which provides us an output. So that was a basic concept of perceptron. If you just study neuron and how neuron works, you can get a better idea of how a perceptron will work. But there are a perceptron does not fully copy a neuron, because neuron is a very complex structure. Like, it consists of millions of inputs, and then it processes, and then it provides its output, and then that output can be the input of other neurons. But unlike our perceptron, it just consists of a few inputs like this, and then it shows us an output, and that output may or may not be connected. And then there is a concept of neuroplasticity inside neuron. Uh, like uh, the the input nodes of neuron can shrink or they can get thick depending upon the strength of the signal. But our perceptron are not like that. They're pretty simple and they don't have such functionality. So this thickness and weakness basically helps the nucleus or the hidden layer of the biological neuron to define which signal to give more importance to and which signal to particularly neglect. So perceptrons are basically math functions, and representing a line equation, and they can be also called as binary classifiers and are used in supervised learning. They either can classify an object into 2 or 3 classes depending on upon the level of inputs and outputs. So that was it from perceptron. Peace.